For this lesson, we're going to look at solving word problems, and I'm pretty picky about how to solve a word problem, so I'm going to make these a little bit bigger. I use what's called a four-step plan. You're not going to like it at first. You're going to find that it's extra work at first, but it will help you become a much better problem solver in the end, and you'll be able to solve most problems. So let's start with number one. It's fairly simple. To start your four-step problem solving process, you're going to draw 4 boxes essentially. This first box here is called your let statement. And the first thing we need to do when we solve a problem is determine what is it that we don't know. What are we going to let our variable equal? And as we look at the problem, it says 8 more than a number is 25. Well, what is it? And it's understood or implied that we're going to solve or find the value of that number. So what is it that we don't know? We don't know what the value of the number is. So if I don't know what the value of the number is, that's what we're going to let our variable be. So we're going to let x equal a number. And you can choose any variable that you want. So we've defined our x as a number. Then the second box is where we're going to write our equation to solve. So we're going to solve, or we're going to translate this sentence into an algebraic equation. 8 more than, technically the word more than here, let's see if I can get my highlighter here. The word more than, hold that thought, the word more than, and I want a yellow color. Okay, so the word more than, that means that we're going to take the 8, oh, forgot I was still on my marker. So we're going to take 8 and then the number, which we've identified as being x, and we're going to flip-flop those. So anytime you have less than or more than, you technically should flip-flop them. So in problem 2, or section 2 here, more than means addition, and then we're going to flip 8 and a number. So our number is x and 8. So x plus 8 means 8 more than a number. Is, the word is always means equals, not always, but predominantly, and then 25. So we've taken the words out of the problem and just made an equation. And from here it's pretty simple. So the third box is really here for you to give you room to solve your equation. So we're going to draw our brick wall, we're going to isolate our variable, and we're going to subtract 8 from both sides to do that. So our 8's cancel, and we end up with x equaling 25 minus 8 is 17. So the value for x is 17. What we're trying to figure out is what is the value of that number. So solving for x has actually answered the question. And so that brings us to the last box. The last box is called your therefore statement. So it kind of makes you sound kind of snooty. You're going to say, therefore, the value of the number is 17. Or therefore, the number is 17. What you're not going to do is write out, therefore x equals 17. So there's no equation in a sentence. You have to use all words. So, therefore, the number is is 17. That's it. So let's look at that with example 2. So you try example 2 on your own, following that 4-step plan, and I'm just going to do it quietly. You can pause the video at this point so that you can do it, and then restart the video. All right, so there's your solution for number 2. Hopefully you did well. Let's look at number 3. Number 3 says twice a number which is decreased by 7 is 35. So very similar, but the equation itself is a little bit more complicated than the first two. So let's define our variable. What is it that we don't know? Again, we're trying to find a number. So we're going to let x equal a number. Part 2, let's write our equation. So you'll notice that problem 3 and problem 4 look almost identical. Twice a number which is decreased by 7 is 35. Twice a number decreased by 7 is 35. So which is, the word which is here, is actually, I'm going to highlight that for you. So which is the difference between the two sentences. So how does that affect our equation? Listen to how I pause in my voice when I read sentence number 3. Twice a number which is decreased by 7 is 35. So if you want to think about it, there should be parentheses or commas right there. So what's being decreased by 7? Is it twice the numbers being decreased by 7, or is it just the numbers being decreased by 7? So in number 3, it's just the number that's being decreased by 7. And then you're going to take twice of that. So it looks like this. Twice a number, so here's twice, the number, which, oh, by the way, is decreased by 7. You use parentheses. So 2 parentheses, x minus 7, is equals 35. And if you look at number 4, our let statement is going to be the same. So we're going to let x equal a number. And then this time, twice a number decreased by 7, it's the twice the number that's being decreased by 7. So twice a number would look like 2x, and it's being decreased by 7, and the value is 35. You're going to get 2 very different answers for both of these. So they don't give you the same answer. So I'm going to quietly solve and come up with the answers, and you are too. So go ahead and solve both of those equations. You can pause the video and then start it back up again. So as you look at the solution for 3 and the solution for 4, notice that for 3, I'm putting in here that x is equal to 49 halves or 24.5. Because this is a word problem, a decimal is appropriate. And so we can also use, instead of the word therefore, a triangle of dots replaces the word therefore. So therefore, the number is 24.5. And in number 4, therefore, the number is 21. So as you can see, both 3 and 4 had different solutions, even though the wording looked very similar. So let's look at number 5. I'm going to make it just a little smaller so we can read all of it. So for number 5, it's really a geometry problem. It talks about the sides of a rectangle. So oftentimes your let statement can actually be a picture. So because it's talking about a rectangle, I'm going to draw a rectangle. It says the sides of a rectangle are x and x minus 4. Since x minus 4 is smaller than x because of the subtraction, I'm going to let the width be x minus 4 and the length be x. And then we're going to take, so really the first sentence was, the purpose of the first sentence was to set up our let statement. So this is our let statement. And the second sentence is to help us set up our equation to solve. And it says the perimeter. So you need to know something about perimeter of a rectangle. To find the perimeter of a rectangle, that formula would be perimeter equals twice the width plus twice the length, or just add up all the sides. It's the same thing. So they've given us the fact that the perimeter is 87, so we're going to replace P with 87 equals 2 times, and then our width is getting replaced with x minus 4. That's what we defined it as. Plus 2 times, and our length is getting replaced with x. So we are going to solve that equation. I'm going to distribute the 2, so I get 87 on the left equals 2 times the x is 2x, 2 times the negative 4 is negative 8, 2 times x is plus 2x. So now I've got like terms on the right, so I want to collect those before I can start to solve. So 87 equals 2x plus 2x is 4x minus 8. My goal is to isolate that 4x, so I'm going to add 8 to both sides. So my 8's cancel, and then 87 plus 8 is 95 equals 4x. And to solve for x, divide both sides by 4, and I get x is equal to, and again, I'm going to use a decimal because that makes more sense. Nobody walks around going, the length of the side of a rectangle is 95/4 units. I don't know what that means, so we're going to change that into a decimal. So 4 goes into 9 twice, with 1 left over. 4 goes into 15 3 times. 4 times 3 is 12, with 3 left over. 3/4 is 0.75. And that's units. So the question says find the lengths of the sides. So this time we've solved for x, and it doesn't quite answer the question. So it's really the purpose of our therefore statement is to make sure that we've answered the question. So therefore, ... answer the question. The length, or the lengths, of the sides of the rectangle are, so if x is 23.75, so that's one of them, 23.75, then x minus 4, we're just going to subtract 4 from 23.75, and we get 19.75. And 19.75 units. I don't know what unit of measure is, so we'll just use a generic units. Number 6. So for number 6, it says there are 22 students in a classroom. There are 12 more girls than boys. Find the number of boys in the classroom. So when we define our let statement this time, you have to define everything that we're talking about. They have mentioned boys and they have mentioned girls. One of those is going to be just a plain variable, whether it's x, whether it's g, whether it's b, you decide. But what we do need what we do need to do here is define both boys and girls, because that's what we're talking about. We're talking about number of boys and number of girls. We do know that there are 22 total, and so that's going to help us with our equation. But most specifically here, it says that there are 12 more girls than boys. Who do we know nothing about? There are 12 more girls than boys. So if we knew the number of boys, wouldn't we be able to find the number of girls? So we know absolutely nothing about boys, but we know that there are 12 more girls than there are boys. So if I were you, I would let boys be B, and girls are going to be 12 plus B, or B plus 12. Honestly, it doesn't matter which one. So how do we write our equation to solve? If the number of boys is B and the number of girls is 12 plus B, and we have a total of 22 students, which includes boys and girls, wouldn't the sum of those two be equal to 22? So that's our equation. The number of boys, which is B, plus the number of girls, and I'm going to write it as B plus 12, because some of you it bothers you if we don't, should total 22 altogether. So again, this is the number of boys, this is the number of girls. Together, they should add up to 22. So we do have like terms. We have 1B and 1B, which gives us 2B's plus 12 equals 22. Now we have a two-step equation to solve. Let's isolate the 2B by subtracting 12 from both sides. 12's cancel. You have a 2B is equal to 10. When you divide by 2, we get B is equal to 5. What does the question ask? The question says find the number of boys. Does that answer the question? Yes. We don't have to go plug it back into 12 plus B, because they don't care about the number of girls. They only care about the number of boys. So we've actually solved the problem. So therefore, restate the answer, or restate the question, find the number of boys in the classroom, as an answer. So therefore, as a complete sentence, the number of boys in the classroom is 5. Now, if you stop to think about your answer, you're like, well, there can't just be 5 boys. That doesn't sound right out of 22. Well, let's think about it. If the number of boys is 5, then the number of girls is 12 more than that. So 5 plus 12 is 17. So there are 17 girls in the class and 5 boys. Do they add up to 22, 17, and 5? Yes, that equals 22. So it is a reasonable solution. Let's look at the last problem, number 7. Alan has $6 more than Bill. Together they have $30. Find out how much money Bill has. So this really isn't much different than the one that we just discussed, except for it's discussing money. So let's define our variables. The two things that we're talking about would be Alan and Bill. So we're going to let Alan equal and Bill equal. Those are the two things that we have to define. Which one do we know nothing about? You were told that Alan has $6 more than Bill. They're telling you something about Alan. He has $6 more than Bill. We know absolutely nothing about Bill. Since we know nothing about Bill, we're going to let Bill be the single variable. You can let him be X, you can let him be T, whatever. I'm going to let him be B for Bill. So if we know that Bill is B, how do we define Alan? Well, you were told Alan has $6 more than Bill. This is how much money Bill has. $6 more than that would be Bill plus 6. Then they go on to tell you something else to help you set up your equation to solve. Together they have $30. So this plus this is $30. It's not just Alan, B plus 6. I realize that kind of looks like a a 10. Sorry about that. But it's not just Alan equals 30, it's Alan plus Bill. So we're going to take Alan, which is B plus 6, and add Bill, which is B, and together their money should add up to $30. So now let's solve this. We've got like terms there, so that gives us 1B plus 1B gives us 2B plus 6 equals 30. We want to isolate the 2B, so to get rid of a positive 6, we're going to subtract 6 from both sides. The 6's cancel. We have 2B equals 30 minus 6 is 24. Divide by 2. And B is equal to 12. The question says, how much money does Bill have? Does that answer the question? Bill is B. We solve for B. Yes. So Bill has $12. If they asked us what Alan had, it would be $12 plus $6, which is 18. What is 18 plus 12? That is indeed 30. So it does appear to check. So let's answer the question in a complete sentence. Therefore, we are going to answer this question, find out how much money Bill has as a complete statement. Therefore, Bill has $12. Whoops, let's put 12 in there. And that's word problems. The next slide, which you're going to see on here, is just the homework. And so we're going to stop the lesson here.